Algebra lesson 3-4. More multi-step equations, but some special situations. Looking at possibly whether or not we'll actually be able to find a solution. If so, how many solutions there might be. So our first thing we want to think about in considering all of this is the idea of an identity. An identity is going to be any time we have any value of x that will work. In other words, there is not just one answer, there's a whole bunch of answers. Both sides are going to be equal to each other when they're solved. We'll go through the exact same shuffling process that we've been working on. What we do to one side, we do to the other. And eventually, when it all gets done, all the x's will cancel themselves out. And we'll be left with a number equal to itself on the other side. For example, it might say 5 equals 5. It might say 1 equals 1, or negative 7 equals negative 7. But one side will be exactly the same as the other side. And as we get more familiar with these, we'll be able to tell that we'll have the exact same thing on both sides even earlier. So an identity is any time one side is equal to the other, and they look exactly the same. That means that any number works. There isn't just one answer, there's a ton of answers. No solution. A no solution, when we solve, go through the whole shuffling process, and we end up having unequal numbers at the end. Say we have 5 does not equal 7, or 9 does not equal 26. So the x's have canceled themselves out, and there's nothing left except two numbers that are not equal. That's a no solution. So we have three scenarios. We have identity, where the two numbers are equal to each other. We have no solution, where the two numbers when we solve are not equal to each other. And then we have what we've been working on, where there's exactly one solution, where it says x equals a number. Those are the three possibilities. So I refer to those as one, none, or a ton of answers. Those are your three possibilities that you could have. This first example, 6x plus 22 is equal to negative 3x plus 31. Now we want to play the shuffling game. We got to play some separation here. We got to make a decision, and it doesn't matter what side, but we have to decide, do we want to make all the x's come to the left-hand side, or do we want to make all the x's move to the right-hand side? Again, it does not matter which side, you just have to make your choice. If you decide to move them all to the right, that's great. If you want to move them all to the left, that's great too. It's whatever you'd like to do. We still have to move them using inverse operations. So if I looked at this first problem, I would probably say, I'm going to try to move these negative 3x's away from that side. And the only way I can get rid of a negative 3x is if I add 3x. So here I add 3x. But the rule clearly states that whatever I do to one side of the equal sign, I must do to the other side of the equal sign. I get this all the time. I get people that put plus 3x right here. And that does them no good. Both the 3x's are on the same side of the equal sign, so you must be careful about that. What you do to one side, you must do to the other. So we're actually going to come over here, and I'm going to add 3x. Now on occasion, I've seen people put the 3x right here. We don't want to put it underneath the 22 because they're not like parts. We want to put it underneath the 3x because they are like parts. Now, we can go ahead and we can add these. I'll get rid of my middle. The negative 3x and the positive 3x are opposites of each other. They cancel out. 6x plus 3x is now 9x. We still have 22 here, and that equals 31. So we're partway onto our step, and once we've done that, once we've gotten all the x's on one side, you might recognize this as some of the problems from before. A two-step equation. Now, if we move all the x's to the left, that means the stuff without x's needs to move to the right. We want to get them away. We want to separate the stuff that has x's away from the stuff that does not have x's. So I'm going to add negative 22 to both sides. Now those cancel out, and I'm left with 9x is equal, and when I do this, do I have more positives or do I have more negatives? I have exactly 9 more positives. So I haven't completely finished it yet. I'm close. I have to divide both sides by 9, because that's the opposite of multiplying by 9. And now I end up with x equals 1. If that's correct, I should be able to put it in anywhere in this problem and have it be true. Let's go back to the beginning. We said x was 1. 6 times 1 is 6. 6 plus 22 is 28. Negative 3 times 1 is negative 3. Negative 3 plus 31 is also 28. So I know it works. So this is a situation where there's exactly one solution because it says x equals that number. 64 minus 12w is equal to 6w. Now we have to play the shuffling game. Before we do that, I'm going to make a quick adjustment. Instead of subtraction, I'll make that plus negative 12w. If I look at this problem in terms of the equal sign, on the left-hand side I have stuff without w's and I have stuff with w's. On the right-hand side I just have stuff with w's. So it makes sense in this problem, though it doesn't matter, to move all the w's onto one side. So I will add 12w here, because that's how I get rid of a negative 12w. Then I'll add the 12w over here. These now cancel out, and I have 64 is equal to 18w. Now we're not finished. Now we have one more step, and that's to completely isolate the variable. So I will divide by 18. Divide by 18. The 18s cancel out, and I'm left with a scenario where 18 doesn't go exactly into 64, but I can simplify it. I could take 64 over 18. There's a number of ways, but I could look at this and I could say, I know that 2 goes into both, so that would make 32 over 9, because they're both divisible by 2. And at this point, 9 can go into 32 exactly 3 times, and that would make 9 times 3 is 27, so there's 5 of those left, 5/9. 3 and 5/9 is equal to w. Now that's again exactly one solution because it says w equals the 3 and 5/9. Had you used a calculator, it would have come out to 3.5 repeating on forever as w. But the fraction is perfectly fine. Alright, so even though there's multiple x's on each side, that doesn't matter. Just pick a side and get all the x's to that side, and then whatever doesn't have x's has to go to the opposite side. So they're always away from each other. You're constantly playing the separation game. And it is possible that when you solve, that you might come up with what we would, seem to be kind of a funky answer because of the 3.5 repeating. Don't stress about that. Just check your work and make sure you've done it correctly. And it's okay to get an answer that's not always an integer. We have some parentheses on one side, no parentheses on the other. We do have signs. I'll make a quick adjustment to this, plus negative, plus negative. I'm also going to put a 1 in front of that x. Now it's really hard to compare this side or play any of the shuffling game when the parentheses are in the problem. So we're going to use the distributive property, making sure that we take the number 4 and multiplying it by both of the terms inside the parentheses. 4 times 1x is 4x. 4 times negative 5 is negative 20. Over here I got 4x plus negative 20. They look awfully similar, which in fact they are. They're identical to each other. This is an identity problem, but maybe I don't see it just yet, and I'm still going to play the shuffling game. If I'm going to play the shuffling game, I've got to make a decision. I'm going to move all the x's to the left. In order to move the x's to the left, I got to get rid of a positive 4x, which means I need to add negative 4x to both sides. Now that I've added negative 4x to both sides, these cancel out, and those cancel out, and I get negative 20 equals negative 20. Those two numbers are identical to each other. That means that this is an identity answer. Remember we talked about this at the beginning? An identity is any value of x will work. And it's any time you get done solving, you have two numbers that are equal to each other. And we do have that right here. We have 20, or negative 20 equals negative 20. It won't matter. You can pick any number you want. If you want to put 100 there, and put 100 there. They'll be exactly the same. 3x minus 9 equals 3x plus 10. Make an adjustment. Plus negative 9. This time I'm going to move all the x's to the right, so I'll add negative 3x, because that's how you get rid of a positive 3x. And these 3x's cancel out because they're opposite, and what do you know? Those two cancel out because they're opposite, leaving us with negative 9 equals 10. Is it possible for negative 9 to equal 10? No, that is not possible. This is a no solution. So you'll notice with the no solutions that the x's have canceled out, and you have two numbers that are not equal. With an identity, the x's have canceled out also, but the two numbers are equal. And if it's one solution, the w won't cancel out, and it's equal to a number. So you'll have 1, none, or a ton of answers. Those are your three possibilities. Some adjustments. plus negative, use the distributive property. This is really like negative 1x. Over here I'm good, but I'm going to use the distributive property, possibly. I can't add this 4x to that 1x because the 1x is in, negative 1x is inside parentheses. But once I distribute it, I'll have 20 plus negative 10x plus 4x equals negative 3 tenths x plus negative 9 tenths. Now it's not super enjoyable to have those tenths on there, so we'll deal with that in a moment with a little trick. But before I get carried away, I have some like parts. I can simplify this down. So now I have 20 plus, there's more negatives than positives, negative 6x equals negative 3 tenths x plus negative 9 tenths. Now, here's the trick. To get rid of the fraction in this problem, I know that in the past we've multiplied by a reciprocal, but that will only get rid of one of the fractions. If I multiply the entire problem by a common denominator, which these two have denominators of 1, and these two have denominators of 10, so a common denominator is 10. If I distribute this to all four of those sections, I'm going to have 10 times 20 is 200. I'm going to have 10 times negative 6x is negative 60x. I'm going to have 10 times the negative 3 over 10x, which means the 10s would cancel out, leaving me with negative 3x. And I'm going to have 10 times the negative 9 tenths, the 10s would cancel out, leaving me with negative 9. The whole idea I multiplied by 10 was to cancel out those 10s. Now I can play this shuffling game just like before. I'm going to get all the stuff with one kind on each other side, so I'll add 60x here, add 60x here. These cancel out, leaving me with 200 is equal to 57x plus negative 9. All I have to do is move the 9 to the other side. This is all exactly the same as what we've been doing in the past. Those cancel out. 209 equals 57x. So I'm one step away from having this completely solved. I just need to divide both sides by 57, and I would have my answer. Divide by 57, divide by 57. X equals, now I can leave it as an improper fraction, 209 over 57. Or I could see how many times 57 can go into 209. It's pretty close to 4, but it's not enough. I mean, there isn't enough in 209 to make it exactly 4. So this is going to be 3 and something, but I can just leave it as an improper fraction, 209. If I really want the decimal version, I'll just take 209 and divide it by 57. One more to look at. This one's very similar. You just have to be very careful right here to make this plus negative 4 and plus negative 3 and a 1x there, so that when you distribute, you don't lose track of your signs. Now, 2/5 times 10x. What's interesting is 5 can go into that 10, so I'm actually looking at 2 times 10 is 20 over 5 makes 4x. 2/5 of 10 is 4. Plus, 2 times the 15 is 30 over 5 makes 6. Now, distributing that right there actually came out to be pretty easy. Equals 18 plus negative 4x plus positive 12. That's the one where most people make the mistake. Now, before I start playing the shuffling game, you've got to recognize that you have some like parts here and here. So we now have 4x plus 6 is equal to 30 plus negative 4x. Now decide which side you want to move them all to. I'm going to move them all to the left as far as the x's are concerned, so I'll add 4x here, add 4x here. Those cancel out. 8x plus 6 is equal to 30. Since I moved the x's to the left, the stuff without x's has to move to the right. 8x now equals 24. Divide by 8 on both sides. And x equals 3. Now the problems are getting bigger and there's a lot more work involved, but it's all based on little things that you know, like distributive property and the shuffling game. As long as what you do to one side you do to the other, you'll be okay.